Python is an interpreted programming language. When we program Python, the errors we may encounter can come in three flavors. We could encounter a syntax error, we could encounter a runtime error, or semantic error. When we encounter syntax errors, those are errors where our code is not valid Python code, and I think usually that is it's easy to fix. Now, when we encounter runtime errors, these are errors that are syntactically valid code, but then somehow they fail to execute. Perhaps due to invalid user inputs, and sometimes they are easy to fix depending on the context. And then the semantic errors, these are errors due to the errors in logic. So our code executes when we encounter semantic errors. Usually, our code executes without a problem, but then the result is not what we would expect. So, depending on the context, again, these errors can be quite difficult to identify and fix. So, in this tutorial, we're going to be looking at specifically, we're going to be looking at runtime errors, and then we're going to be looking at how we can manage these errors gracefully. So, we're going to be talking about things like try and accept block. We're going to be talking about raising exceptions. We're going to be talking about try, accept, else, finally block, things like that, so that we have some kind of a safety net for our code in event that they throw an exception, things like that. So I'm gonna go to IPython. Okay, coming. So let me open. I'm gonna open terminal here, and then I'm gonna boot up IPython so that we play with. We implement some programs to demonstrate error handling and exceptions. So here I'm going to zoom in. Okay. Okay. So I'm going to boot up IPython, and then we're going to see how this goes. Okay. So now we're in IPython. So if you have give an instance, say we have print q, for instance. Now this blows up. This is name error. This is an example of a runtime error. So say name q is not defined. Okay. We could have say 1 plus ab, for instance. Okay, now this is another error, type error, unsupported operand type S for blah blah blah. Okay, so this is a type error. See, it's blowing up. If we have L, is this L is we have 1, 2, 3 like that, and then we come here to say 50. Okay, now this is index error. Okay, now if we have a float constructor, say float, and then in here we say 3.142 like that, no error. So float typecast, what we have here, even though it's a string, but then it's a numeric value. The string contains a numeric value. So float constructor is able to typecast this into float. Okay, if we have floats, and here we have 200, obviously it's typecasting this into float. So our float constructor function is expecting what is it called? Three arguments, three types of argument. It's expecting numeric type, it's expecting the float type, and if we're passing a string, that string has to have a numeric value. So if we do, for instance, if I do float, and then in here I do some string, and this blows up, we have value error, could not convert string to float. Now, all of these errors that we have, you see, they look nasty. The whole point of error and exception handling is so that we can undo these errors gracefully. So how do we do that? The way we do that is to implement this try except block. So I'm going to go back to this float thing, like say try, for instance, and then we could have what is it called? We could have float. Float. Should I do this? Okay, you know what? Let me use a function. Say def try float, like that, and then let's this takes an input. Okay, and then I could do return float x, like that, and then oh no, I'm making a mistake, sorry. I'm trying to implement try except, so here it should have been try, and then here you can say return float, then I pass x into it, and then I can do except return x. So this is going to return whatever argument we pass here when we call our function, in the event that we got an exception anyway. So here I'm going to break out of here, and then I can invoke my try float function. Okay, so let's say here I pass, what do I pass? If I pass 2.132, okay, no, 2.132, like that. Okay, so now the way try except works is this. If the code in our try block executes, this except block doesn't get executed. What I'm saying is, if the code in our try block did not throw an exception, then the except block does not get executed. But then if the code in our try block threw an exception, okay, so the program here halts and then proceeds to the except block, so that we handle our error in a graceful manner. So you can see now that here, when we pass a string representation of a numeric value, okay, we got, of course, try float, which is returning a float constructor. It just typecast this, so this works. So the except block never got executed in this code, in this program. So if we do this, for instance, and then here we pass floating, now we got floating. So it didn't blow up like before, we got floating. Okay, so you see that this looks much cleaner compared to what we're doing the other time. This is still an exception. This is value error. This is value error. But then we are returning the inputs we pass into our function when we invoke it here. So the whole thing doesn't look nasty. Okay. Now we know that this is value error because up here we've sort of like, okay, no, we've sort of like tried something similar. Okay. So what if we suppress that value error, like we try to what is it called, we try to catch that value error if that language applies to what we're trying to do here. So we can explicitly try to suppress that value error by doing, we can re-implement our function, and then we can do try like before, and then we can do return float x, and then here we can do except what, value error, except value error. Okay, and then here we can do print error, error, okay, error, error, sorry, you enter the wrong value. Okay, and then here we can just return none, like that. Okay, so here when we invoke our function and then we got value error, this is what is going to get printed, and we're going to return none. None in Python is null in another programming language. Okay, so let's break out of here, and then we can try float. So this is going to give or get us value error. Now let's see what is going to print out. So it says error, sorry, you entered the wrong value. So return null is null anyway, so we don't get anything related to that. So you get the idea. So we're trying to like, we're suppressing the value error here so that when this try block throws an exception, because now when we invoke this function, the input we pass is string, and that's not what our float constructor is expecting. A float constructor is expecting numeric value or a string that contains a numeric value. So it's not expecting a generic string, but then we pass generic string. So that what that returns is a value error. So this block is going to halt execution when we invoke this, because we've gotten an exception, and the exception we've gotten is this value error. So we're explicitly suppressing this value error here, and then so when we got the value error here, it just goes to this next block, which is the except block, and then it prints this. Now you realize this looks elegant compared to when things were just blowing up abysmally the other time. Okay, now one thing you may have discovered on your own, or maybe you're about to discover now, is the float constructor doesn't just throw value error. It could throw another error. For instance, if I call float, and then in here I pass a tuple 1 2 like that. Let's see what it got. Now we get type error. See? But we've not been handling type error as regard our float constructor. See? So even if I go here, if I go back to our function, and then I do try float, and then in here I pass tuple. I pass tuple 1 3 this time. What am I doing? Now, even though I've implemented an exception block here, which is suppressing a value error, well, because we didn't implement, we didn't suppress type error, this will still blow up, and we're still going to get a nasty error. See, type error, float argument must be a string or a real number, not tuple. Okay. So, depending on what you're trying to achieve, you might leave this, you might not try to suppress type error because this is a legit error in your program. But let's say you wish to suppress this type error in your program, then we can do something like def, like that, and then we can do try, like before, and then we can say return float x, like that, and then we can do except. Now in our except, we can pass in a tuple, and then we can do value error, type error. So we want to, when we do this, we're trying to suppress both value error and type error. So we can do print we've encountered value error, value error, no value error, or type error. Okay, let me leave it like that, and then we can return none here. Okay, none, like that. So if I now do try float, watch this, this doesn't blow up anymore. This, because when I do this, this try block does not execute, so it goes on to the next block, which is except block. And then because we are printing out this message to elegantly handle this for us, we're going to get this instead. So if I do enter, I say with a counter value error, type error. So if it does not throw an exception, then we can still get something like so we say 100 now. So this doesn't throw an exception. Well, I hope you're getting the idea of error handling. So the whole idea is to help us undo errors gracefully when we are programming. Okay. What if we wish to raise error of our own? You know, we can do that. Now, or before we do raising error of our own, we've talked about value error. We've talked about type error. You know, let's try one more example. What if we did x equals 1 divided by 0? See? This is zero division error. Okay. So we can undo zero division error much like we undo this here. So we can do def save divide, for instance, save divide, and then pass a parameter here, and here we can do try. Again, we're doing try catch, try except, sorry, and then we can say return. No, what should we do now? Return. I want, or should I not do that? So, return 10 divided by x. Okay, I think I'm going to want to do that. And then I can do except. Okay, so now we do except 0 division, zero division error, like that. Okay, now we do print invalid divisor. Please try again. Okay, and then here, what do we do? So let's just return x so that we see what we entered. Okay, so I'll break out of this, and then when I do save divide, Remember, it's returning 10 divided by whatever input we pass into our function. So if I do 2 now, this works, no error. Okay, if I do save divide and then I pass 0 as our denominator or as our divisor, then let's see what we get. We get invalid divisor. Please try again. And then we got what we entered here. Okay, so you realize that unlike the other time when it just blew up nasty, here it looks clean. Okay, now what if we wish to raise our own error? So we wish to raise exceptions on our own. We can do that, but then you may not really appreciate the significance of that until you actually encounter the error. So I'm going to write a program that should throw some kind of error, and then we're going to come back and re-implement it in such a way that we can raise exception when we encounter such an error. So you're familiar with this if you've been following with our tutorial series. So Fibonacci, I'm going to pass n here like that. Okay, and then let's have L, which is an empty list, and then we can have A, B equals 0, 1 like that, and then we can have Y length of L is less than n. What do? Then let's say A, B equals to B, A plus B. If you've been following through with that tutorial, you understand this code already. So I'm not going to waste our time explaining this. And then we can do L dot append A like that. So we can break out of our Y block, and then we can do return L like that. Okay, so if I call Fibonacci now, Fibonacci, and then in here I pass 10, this works. It doesn't blow up. Remember, we're saying Y length of L is less than n. Do this. So A, B, then B, A plus 1, 0, 1. So 0, 1, then so it's starting 1, 1. No, I said I'm not going to waste much time explaining that. Okay, so this is what we have. Now, we said the condition is Y length of L is less than n. Do this. What if we did this? Fibonacci, and then we pass in -5. Watch this. We get empty array. So empty list, okay? Because this condition, what we did here, this argument, it doesn't satisfy our Y condition. Because we're saying, okay, Y length of L is less than n. Then do this. Length is an array. L it's a list. I don't know why I keep calling array. L is a list, and when we say the length of our list, for as long as it's less than the value that we pass in here, then let's generate our Fibonacci sequence. Except that, well, -5 is the other way around, because now it doesn't satisfy this condition, so we're getting empty list here. Now there's a way we can do this in a cleaner. There's a way we can do this. What is that? What's that word again? Is it cleanly? Okay, so we can do def, for instance, and then we have Fibonacci like that, and then we say, okay, what do we do here? We can say if n is less than 0. Okay, so that's what do we want to do. Then we can raise an exception. Raise, okay, so that's a value error anyway. So raise value error, like that. So this can take an argument. I think we didn't talk about this before now. So this can take an argument, and an argument can be a string. So we can say n must not be negative. Say n must not be negative, like that. Okay, so we can break out of our if statement, if block, and then let's implement the next logic. Now we have to specify our list, like that, and then we can do a b equals to b, no, 0 1, 0 1, and then we can do y length of L is less than n, like before. Then we can do a b equals to b a plus b. Okay, and then we can do L dot append a, like that, and then out of the y block, then we can return L. Okay, so what we are saying here is, well, if our n is less than 0, raise value error. So we can do n must not be negative, like that. So now a breakout of our function, and then so Fibonacci here. So if I pass 5, let's see what happens. So it's a value error, n must not be negative. You get that? So we are raising our own exception here. You get that? So there is another construct that we can use where we can print out some kind of result regardless of whether or not our program throws an exception. So that construct is known as try, except, else, finally. So that's how that construct works. So how do we do this? Let's go back to our, what is it called? Let's go back to our save divide function, and then here we can do try. So here we can do return, let's say 10 divided by x, like we did the other time. Okay, and then we can do except, zero division error. Okay, so this is going to handle our zero division error. So we can say print, invalid divisor, like that. Okay, and she will return something. Let's return x, like that. Okay, that's try except. We can do another except, so we can take multiple except, and then we can pass a tuple here. Okay, then we can do type error, value error, in the event that we encounter some kind of value error, and then as e. Okay, and then we can do print bad inputs, like that, and then let's pass in a value. Okay, so this should be f string, not like this, f string. Okay, so no, okay, f string. Now we can pass e here. Okay. So what this except block does is to undo multiple exceptions, and then this just undo the zero division error exception. So let's go to our else block. So else, else, okay. Then let's say we can print success. Okay. So what this else block does is it runs only if no exception occurred. So the else block here is going to print success in the event that our program didn't catch zero division error, nor type error or value error. So if there was no exception in the course of executing this program, this else block is going to run as well. Okay, so then we have the finally. Now this finally will run no matter what. That's what, okay, so we have the finally block. I should break out of this. And then let's go to finally. Finally, we can say print these always. Okay, I'm messing up my spelling. This always runs. So the idea is try except else finally is we're getting some kind of output regardless of whether we encounter exception or not, regardless of whether our code threw an exception or not. So this offers us maybe another layer to the elegance of the way we handle error in Python, or the way we handle exceptions in Python. So I'm going to take that again. If this try block runs, if it executes, this does not execute, this does not execute, this execute, this executes. If this didn't execute, this execute, this executes, and then this executes. This does not execute. This only executes if we didn't get an exception in the course of implementing our code or executing our code. So I'm going to break out of all of this and then let's see what we get. So if I do save divide and then I pass 3 here, let's see, this always runs. So this always runs, and then we get what is it called? We get 3 points blah 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 blah. So we're getting the try block. You see that the two except block, they didn't execute. So we're good. I think the except didn't run here. Okay, because I was hoping it will run. We could get what is it called? Success. But then I only got these always runs, which is this finally, and then I got the result of A. If we did save divide and then we pass 0, let's see what we get. Okay, so sorry, invalid divisor. What is that? So we get 0 division, invalid divisor. This 0 division error, it's been implemented, this except block. So remember we said regardless of what we get, this finally we output. So like it did here, this always runs. We also got this always runs here, and then we're returning our divisor here, which is 0. I don't know if I do save divide, of course, -5. So this always runs. Obviously, we can divide by it, negative number. That's not an issue. So, guys, I hope you learned a thing or two in this session. So the whole gamut of this is error handling in Python gives us a better way, an elegant way to undo, to suppress, to process exception in the course of our program. So I'm going to stop here for now. I'm going to see you guys the next video. Thanks for watching. Bye bye.